Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle with diameter. AB is the diameter of the semicircle. We know that AD equals to 7 units, DC equals to 15 units, and BC equals to 15 units, and we want to find out the diameter of this semicircle, or the size of AB. Okay, so first of all we will do a construction. We will connect together points B and D by a straight line. Actually, angle ADB equals to 90 degrees according to rule number 1. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. Okay, peripheral angle resting on the diameter of the circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually, if we have a circle and suppose that chord AB is the diameter of this circle, then any peripheral angle that rests on the diameter that is AB, for example this peripheral angle, that rests, so angle ACB is a peripheral angle that rests on the diameter of this circle, that is to say it rests on chord AB, that is the diameter of the circle. Then according to rule number 1, angle ACB, this angle equals to 90 degrees. And also, if we have other angle that rests on the diameter of the circle, like this angle that is a peripheral angle, angle AEB is a peripheral angle that rests on the diameter of the circle, therefore it is also equals to 90 degrees. Okay? And then you also, it is possible that the peripheral angle rests on the diameter of the circle from the other side, for example, from this side. This is peripheral angle that rests on the diameter of the circle on the other side of AB. So here angle AFB rests on the diameter of the circle, therefore it is also equals to 90 degrees. Okay, so actually we have angle ADB, that is a peripheral angle that rests on chord AB, that is the diameter of the circle. Therefore, according to rule number 1, this angle is a right angle, that is to say it equals to 90 degrees. Okay, so in the next step we will define the center of the semicircle as point O. Again, point O is the center of the semicircle, and we will connect together points O and C by a straight line. So OC is a straight line, and we will connect together points O and D by a straight line, and OD is a straight line. Actually also BD is a straight line, as I've already mentioned. And we will focus on triangle COD, the green triangle, triangle COD. And we will also focus on the orange triangle, triangle OCB. So we will focus on the green triangle and on the orange triangle. So I write it down. So in triangles ODC, that is the green triangle, and triangle OCD, DC equals to BC equals to 50 units. Side DC of the green triangle equals to side CB of the orange triangle. Both of those sides are equal to 50 units. DC equals to CB. Both of those two sides are equal to 15 units. Okay, DC equals to CB equals to 15 units, and actually OB is the radius of the semicircle because of the fact that it exists from the center of the circle, that is to say from point O, and ends at point B, that is a point on the circle itself. Therefore OB is defined as the radius of the semicircle. We will define the radius of the semicircle as R, and also OD is also the radius of the semicircle for the same reason, because it starts from the center of the circle, that is to say from point O, and ends at point D, that is the point on the circle itself. Therefore that is also the radius of the circle, and therefore OD equals to OB. Both of those sides are the radius of the circle, and also AO is also the radius of the circle for the same reason. So actually OD equals to OB because both of those two sides are the radiuses of the semicircle. And OC is the common side. OC equals to OC. OC belongs both to the green triangle and also to the orange triangle. OC equals to OC, common side. So we actually found out that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, those two triangles, the green triangle and the orange triangle, are congruent according to the rule of side, side, side. Okay, so triangle DOC is congruent to triangle OCB. Okay, triangle DOC is congruent to triangle OCB according to the rule of side, side, side. Actually, rule side, side, side states that if two sides of one triangle are equal, if all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles are congruent to each other. And here we saw that all the sides of the green triangle are congruent to all the sides of the orange triangle. Therefore, according to side rule, those two triangles are congruent to each other. And therefore, we can deduce from the fact that those two triangles are congruent to each other that angle DCO, this angle in the green triangle, is equal to angle OCB of the orange triangle. Okay, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So angle DCO equals to angle OCB okay, angle DCO equals to angle OCB according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define angle OCB as alpha, then angle DCO also will be equal to alpha. Okay, if angle OCB equals to alpha, then angle DCO also equals to alpha. So those two angles are equal to alpha. Okay, so in the next step we will focus on triangle DCB. On this triangle DCB, okay, so in triangle DCB, side DC equals to side CB. Both of those sides are equal to 15 degrees. Okay, DC equals to CB equals to 15 degrees. And we have a rule number 2. Rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, in front of equal sides in the triangle there are equal angles. So I'll read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, so actually we have in front of this side BC we have this angle, and in front of this side DC we have this angle. So according to rule number 2, those two angles are equal to each other. That is to say, angle BCD equals to angle CBD according to rule number 2. Again, according to rule number 2 that says that in front of equal sides there are equal angles. Angle BCD equals to angle CBD. Okay, so if we define angle CDB as theta, then angle DCB that also equals to angle CDB also will be equal to theta. Okay, so so those two angles are equal to theta. Angle BCD equals to angle CBD equals to theta. In the next step, we will define this point E, okay, and then we will focus on the green triangle DCE. And the orange triangle CEB. Okay, those two triangles. First of all, we know that DC equals to CB. Both of those two sides are equal to 15 units. Okay, DC equals to CB equals to 15 units. And EC is a common side. It belongs to both triangle CEB and triangle ECD. EC is common, so EC equals to EC. That is actually common side. It belongs to both of the two triangles. Common side. Again, EC equals to EC. It is a common side. And those two angles are equal to each other. They are equal to alpha. So angle DCE in the green triangle is equal to angle ECB in the orange triangle. Both of those two angles are equal to alpha. Okay, so actually we have two sides and the angle between those two sides that are equal in those two triangles. So actually triangle ECD is congruent to triangle ECB. Okay, triangle ECD is congruent to triangle ECB according to the rule of side angle side, SAS. Side angle side rule. Okay, so those two triangles are congruent to each other according to side angle side rule, and actually side angle side rule states that if two sides and the included angle of one triangle are equal to two sides and the included angle of another triangle, then those two triangles are congruent to each other. Okay? Actually, we have this side that equals to this side. This is the common side, and this angle equals to this angle. Therefore, according to the side angle side rule, those two triangles are congruent to each other. Okay? So, because of the fact that those two triangles are congruent to each other, we can deduce that DE equals to EB. DE, side DE of the green triangle is equal to side EB of the orange triangle, according to the rule that corresponding sides in congruent triangles are equal to each other. So DE equals to EB. And also angle DEC in the green triangle equals to angle BEC in the orange triangle. Okay, angle DEC in the green triangle is equal to angle BEC in the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. So this angle is equal to this angle. Those two angles are equal to each other. So if we define angle DEC as X, so if angle DEC is defined as X, then angle BEC also will be equal to X. Okay, so angle BEC will also be equal to X. Okay, so actually if we add together angles DEC and angles CEB, we will get that angle DEC plus angle BEC equals to X plus X, that equals to 2X. So actually this angle equals to 2X. Okay, this angle equals to 2X. But what is this angle? This angle is actually angle DEB. This angle is angle DEB. So we concluded that angle DEB equals to 2x from one side. Angle DEB equals to x. DEB equals to 2x. Okay? X plus x is 2x. So this angle equals to 2x. From one side, angle DEB equals to 2x. But from the other side, because of the fact that DB is a straight line, then the angle, the sum of the angles at point E on one side of the straight line DB, if we sum the angles on one side only around the point E of the straight line DB, it will be equal to 180 degrees. So actually the sum of the angles on one side of a straight line, that is DB is a straight line, and the sum of the angles at one side of the straight line, of any straight line, is equal to 180 degrees. So we look, if we look on the upper side of angle DB, then the sum of the angles on the upper side of straight line DB at point E will be equal to 180 degrees. So angle DEB equals to 180 degrees, because of the fact that the side DB is a straight line, and we added the angles, the sum of the angles. We calculated the sum of the angles only at the upper side of the straight line, and the sum of the angles at certain point on the upper side of a straight line equals to 180 degrees. Okay, so if we focus on at point E, and the upper side of straight line DB, and then the sum of the angles on the upper side of straight line DB at point E will be equal to 180 degrees. Okay, so angle DEB equals to 180 degrees from one side, but it also equals to 2x degrees at the other side. So from this equality, we can deduce that 2x equals to 180 degrees. 2x equals to 180 degrees. And if we divide this equality by 2, x will be equal to 180 degrees over 2 is 90 degrees. Okay, so we concluded that x equals to 90 degrees. Okay, this is x, as you can see. So instead of x, I will draw a right angle. So this is a right angle, and this is also x, and it equals to 90 degrees. So this angle is also a right angle. So those two angles are equal to each other, and both those two angles are equal to 90 degrees. Okay, so angle DEC equals to angle BEC, and both those two angles are equal to 90 degrees. Okay, and in the next step, we will focus on the straight line OC. OC is actually the radius of the semicircle. OC equals to R because it exits from the center of the circle, that is to say from point O, and touches the circle at point C. Therefore OC is the radius of the circle. OC equals to R and is a straight line. OC is a straight line. Therefore, if we focus only on one side of this straight line, for example, if we focus on the right side, for you it is the left side, for me it is the right side. Okay, if we focus on the left side, of the straight line OC, then if we focus only on one side of this straight line at point E, then the sum of the angles on the left side of the straight line OC at point E will be equal to 180 degrees. So this angle will be equal to 180 degrees because of the fact that the sum of the angles at one side of a straight line is equal to 180 degrees. Okay, so actually that means that angle CEB, that is actually 90 degrees, plus angle BEO, must equal to 180 degrees because of the fact that the sum of the angles at one side of any straight line is equal to 180 degrees. Okay, so we have this equality that states that angle CEB that equals to 90 degrees plus angle EBO equals to 180 degrees. Okay, because of the fact that the sum of the angles at one side of a straight line equals to 180 degrees. So we can subtract 90 degrees from this equality, and we will get the equality that states that angle BEO equals to 180 degrees minus 90 degrees equals to 90 degrees. Okay, so angle BEO equals to 90 degrees. Angle BEO equals to 90 degrees. So actually this is a right angle. Okay, actually we have around point E, we have three right angles. 1, 2 and 3. We have three right angles around point E. Okay, angle DEC is a right angle, angle CEB is a right angle, and angle OEB is a right angle. Okay, and we know that the sum of the angles around any point must be equal to 360 degrees. So the sum of the angles around point E must be equal to 360 degrees. So the sum of the angles that is around point E that is must be equal to 360 degrees minus of the sum of these three right angles, that is actually 90 times 3 is 270, will be equal to the missing angle, to the fourth angle, that is angle OED. Okay? Again, the sum of the angles around point E is 360 degrees. So 360 degrees minus the sum of the three right angles, that is actually 270 degrees, will be equal to the missing angle, that is angle OED. Okay, so 360 degrees minus 270 degrees equals to angle OEB, that is actually 90 degrees. So angle OED equals to 90 degrees. Okay, so the fourth angle is also a right angle. So we found out that all the four angles around point E are equal to 90 degrees. All the four angles around point E are right angles, because angle OED also equals to 90 degrees. Okay, so in the next step we will focus on two triangles, on triangle ADB and on triangle OEB. Actually, I will draw them again. I will draw the two triangles again, and triangle ADB and triangle OED, and triangle ADB and triangle OEB. We know that angle ADB is a right angle, and also we know that angle OEB is also a right angle. Actually, we have here two right angles. So actually in triangle ADB and triangle OEB, this triangle, so in the big triangle, triangle ADB, in the small triangle, triangle OEB, we have two angles that are equal to each other. Both of those two angles are equal to 90 degrees. So angle ADB equals to angle OEB. Both of those two angles are equal to 90 degrees. Okay, and angle B equals to angle B. those two triangles, triangle ADB and triangle OEB, have a common angle, that is angle B. So angle B equals to angle B. It is a common angle, it belongs to both triangles. Okay, so we have two angles in those two triangles that are equal to each other, and angle DAB, this angle will be equal to angle EOE. Again, angle DAB this angle will be equal to angle EOB. Okay, angle DAB will be equal to angle EOB according to the rule, according to the third angle theorem. According to the third angle theorem, those two angles are equal to each other. The third angle theorem states the third angle theorem states that if two angles of one triangle are equal to two angles of another triangle, or we can say if two angles of one triangle are congruent to two angles of another triangle. Okay, you can use the word equal, or you can also use the word congruent. If two angles of one triangle are equal to two angles to another triangle, then the third pair of angles are also equal to each other. Okay, so the third angle theorem states that if two angles of one triangle are equal or are congruent to two angles of another triangle, then the third pair of angles are also equal to each other. Okay? So we actually found out that three angles of the big triangle, triangle DAB, are equal to three angles of the small triangle, triangle EOB. So actually, triangle DAB is similar to triangle OED. OEB. Okay, triangle ADB, the big triangle, is similar to triangle EOB, this small triangle, according to the rule of angle, angle, angle. Okay, according to the rule of angle, angle, angle. Again, triangle ADB is similar to triangle OEB according to the rule of angle, angle, angle. Okay, so from this similarity between those two triangles, we can derive the following relationship between the sides of those two triangles. The following similarity is true about those two similar triangles. The similarity is OB over AB is equal to OE over AD. Again, because of the fact that the triangle ADB is similar to triangle OEB, the following relationship exists between the sides of those two similar triangles. OB over AB equals to OE over AD. Okay, so OE what is OB? OB is the radius of the semicircle, that is to say it equals to R. What is AB? AB is the diameter of the semicircle. AB equals to R plus R. AB equals to 2R. So it is OB, that is R, over AB, that is 2R. R over 2R equals to OE. OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total, we got that R over 2R equals to OE over 7. Okay? R over 2R equals to OE over 7. R over R is 1. So R is cancelled. And we got here 1 over 2. 1 over 2 equals to OE over 7. So I will write it down. One over 2 equals to OE over 7. Okay? We got this equality that states that 1 over 2 equals to DE over 7. Here we will multiply this equality by 7. And we will get that DE, it is OE equals to 7 over 2 units. Okay, OE equals to 7 over 2 units. So here we can write down that OE, this line segment, equals to 7 over 2. Okay, but what is the value of EC? What is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. Again, EC, this line segment, EC equals to OC minus OE. OC minus OE. Again, EC equals to OC minus OE. Okay. EC, this line segment, equals to OC minus EC minus equals to EC, this line segment, equals to OC minus OE. Okay, so EC equals to OC. OC is the radius of the circle, so it is R. And what is the value of OE? We have already found out that OE equals to 7 over 2. So in total, we got that EC equals to R minus 7 over 2. EC equals to R minus 7 over 2. Okay, so actually we have here two right triangles. Triangle OEB. This triangle is a right triangle because this angle is a right angle. Okay, so we will focus on the right triangle OEB. We will focus on the green right triangle ECD. And the right triangle, the right green triangle, triangle OED. So both those two green triangles are right triangles. Those two triangles are right triangles because they have angle of 90 degrees. Okay, so because of the fact that those two green triangles are right triangles, we can implement the Pythagorean theorem on those two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so and DE is a common side for the two right green triangles, that is to say it belongs to both those two right triangles. Therefore we can create the formula that states that DE squared equals to DE squared okay, DE squared equals to DE squared. And we relate to this right green triangle, and we will implement the Pythagorean theorem on this green right triangle. DE squared is actually equals to R squared minus OE squared. Okay, it equals to R squared minus OE squared, OE squared, and DE squared equals to DE squared. DE squared equals to DE squared, and in the other side of the equality we will relate to this right green triangle, and DE squared will be equal to DC squared minus EC squared. It equals to DC squared minus EC squared. So in total we got that R squared minus OE squared equals to DC squared minus EC squared. Okay, so R squared minus OE squared. What is the value of OE? OE equals to 7 over 2, so OE squared will be equal to 7 over 2 squared, and it equals to DC squared. DC equals to 15 units, so 15 DC squared is 15 squared, and 15 squared is 225 minus EC squared. EC, we've already found out that EC equals to R minus 7 over 2, so EC squared will be equal to R minus 7 over 2 squared. So in total we got that R squared equals to minus 7 over 2 squared, that equals to R squared minus 7 over 2 squared equals to 225 minus R over 7 over 2 squared. 7 over 2 squared is 49 over 4. So I write it down. So here 7 over 2 square is 49 over 4, and here I opened the brackets. R over 2 square is R square, plus 7 over 2 square is 49 over 4, minus 2 times R times 7 over 2. So here we have 2 in the numerator of this expression, and we have 2 in the denominator of this expression. So 2 will be cancelled. And here we have minus 49 over 4 in this side of the equation, and we have so I actually didn't open the brackets yet. So first of all, I will open the brackets of this expression. So we will get that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4 plus 7R. So in total we got this equality that states that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4 plus 7R. Here we have minus 49 over 4 in this side of the equation, and we have minus 49 over 4 in the other side of the equation, so we can cancel 49 over 4, and we will add R square to this equality. We will get that R square plus R square is 2R square. 2R square equals to 225 plus 7R. So in total we got that 2R square equals to 225 plus 7R. Here we will subtract 225 from this equality, and we will also subtract 7R from this equality, and we will get that 2R square minus 7R minus 225 equals to 0. So here we have a quadratic equation, and the coefficient of this quadratic equation is actually A equals to 2, B equals to minus 7, and C equals to minus 225. So I write it down. The coefficient of this quadratic equation is capital A equals to 2, B equals to minus 7, and C equals to minus 225. Okay, and we have the general formula for the roots of the quadratic equation. The roots of the quadratic equation is x, when x is the variable of the quadratic equation, Actually, the general quadratic equation is ax squared plus bx plus c equals to 0 when A, capital B, and capital C are the coefficients of the quadratic equation, and x is the variable of the quadratic equation that we want to find out the value of x. So in the general quadratic equation, the roots of the quadratic equation is x that equals to minus b plus minus the root of b squared minus 4 times a times c over 2 times a. Okay, so that is the solution of the roots of a quadratic equation. So the thing that we need to do is to in our specific quadratic equation, the variable is r, the radius of the circle that we want to find out. And we know that capital A equals to 2, B equals to minus 7, and C equals to minus 225. So we will substitute x by r and A by 2, B by minus 7, and C by minus 225, and we will find out the roots of the radius, or the solution, the values of the radius of the semicircle, or the values of r, that is the radius of the semicircle. So we will get that we will substitute x by r. R equals to minus b, b equals to minus 7, so minus 7 is 7 plus minus root of b squared. B squared is b equals to minus 7, so b squared is minus 7 squared. Minus 7 squared is 49. Minus 4 times a. 4 times a is 4 times 2 is 8. Times c. 8 times c, and c equals to minus 225. So over 2a, 2 times a is 2 times 2 is 4. So in total we got that the radius of the semicircle R is equal to 7 plus minus root of 49 minus 8 times minus 225. Minus 8 times 225 is 1800. So minus times minus is plus. So in total we will get that the radius of the semicircle R equals to 7 plus minus root of 1200 plus 39 is 1200. 1200 plus 49 is 1249 over 4. So the radius of the semicircle equals to 7 plus minus root of 1249 over 2. The root of 1949 is 43, so I write it down. R equals to 7 plus minus 43 over 4. Here it is over 4 because 2a is 4. So here we have two possibilities for the radius. The first possibility is that the radius of the semicircle R equals to 7 plus 43 over 4. 7 plus 43 is 50. 50 over 4 is 12.5. Okay, so the first solution to the quadratic equation is R equals to 12.5 units. R equals to 12.5 units. And we have also the second solution to the quadratic equation, or second value for R, or the second root of R. R also can be equal to 7 minus 43 over 4. 7 minus 43 is minus 36 over 4. Minus 36 over 4 is minus 9. So we got that the radius of the semicircle equals to minus 9. And actually, because of the fact that the radius of a circle must be a positive number, R is greater than 0, it is a positive number, therefore this is an incorrect answer. The radius of the semicircle cannot be minus 9, so we left only with one possibility, that the radius of the semicircle equals to 12.5 units. The radius of the semicircle equals to 12.5 units. R equals to 12.5 units. And we know that the diameter of any circle or semicircle equals to 2 times the radius. That is actually AB. AB is the diameter of the semicircle, so it equals also to AB, and 2 times the radius of the circle is actually 2 times 12.5 units. That is to say, 2 times 12.5 units is actually 25 units. Okay, so D that is equals to AB, it actually equals to 25 units. Okay, so the diameter of the semicircle equals to 25 units, or AB, that is the diameter of this semicircle, equals to 25 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle, that is also 2 times the radius of this semicircle. We know that BC equals to 15 units, DC equals to 15 units, and AD equals to 7 units. And we want to find out the diameter of this semicircle, that is AB. Okay, so first of all we made a construction. We joined together points D and B by a straight line, and then we related to the peripheral angle, angle ADB, to this angle. And we have a rule I called it rule number 1. According to rule number 1, peripheral angle resting on the diameter of the circle equals to 90 degrees. So rule number 1 states that any peripheral angle that rests on the diameter of the semicircle, it will be equal to 90 degrees. So if the diameter of this semicircle is 90 degrees, then any peripheral angle that rests on the diameter of this semicircle will be equal to 90 degrees. So this peripheral angle rests on AB, it is the diameter of the semicircle, it equals to 90 degrees. This angle AD also is a peripheral angle that rests on the diameter of the semicircle. The diameter of the circle, for that reason it also equals to 90 degrees. And this angle, peripheral angle, also rests on the diameter of the semicircle, therefore it also equals to 90 degrees. Okay, so actually, as you can see here, the peripheral angle ADB rests on AB, that is the diameter of this semicircle, therefore it equals to 90 degrees according to rule number 1. Then we related to the orange triangle, triangle OCB, and to the green triangle, triangle DCO. In those two triangles, DC equals to CB equals to 15 units. It is given us in the question, so those two sides, the side DC of the green triangle is equals to side CB of the orange triangle, and also OD equals to OB. OD, that is the radius of the semicircle, equals to OB, that is also the radius of the semicircle, and OC equals to OC, it is the common side of these two triangles. Therefore, we proved that triangle DOC is congruent to triangle OCB according to the rule of side, side, side. If you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles are congruent to each other. Okay? So, from the fact that the green triangle is congruent to the orange triangle, we can deduce that angle OCB, OCB is equal to angle DCO. Those two angles are equal to each other. Both of those two angles are equal to alpha, and those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So those two angles are equal to each other. Angle OCD equals to angle OCB equals to alpha, and then we related to triangle DCB. In triangle DCB, this triangle, we know that BC equals to CD. Both of those two sides are equal to 15 units. Okay, so DC equals to CB equals to 15 units, and we have rule number 2 states that in front of equal sides in the triangle, there are equal angles. So those two sides in triangle DCB are equal to each other. And in front of this side we have this angle, and in front of this side we have this angle. So those two angles that are located in front of equal sides are also equal to each other. That is to say, angle BCD equals to angle CBD equals to theta. We define those angles as theta. So those two angles are equal to each other, and they are equal to theta according to our definition. So they are equal to each other according to rule number 2. And then we relate it to those two triangles, to triangle ECB and to triangle DCE. Okay, this green triangle and this orange triangle. In those two triangles, DC equals to CB equals to 15 units, and we know that EC equals to itself. It is a common side of those two triangles. It belongs to the green triangle, and it also EC belongs to the orange triangle. And so angle so we have here one side that equals in the orange triangle that equals to the other side in the green triangle. We have a common side that is EC, and we have also those two angles that are also equal to each other. Therefore, triangle ECD is congruent to triangle ECB. Those two triangles are congruent to each other according to side angle side rule. Okay, so those two triangles are congruent to each other according to side angle side rule. That is to say, if you have one triangle that has two sides and the included angle that is equal to the two sides and the included angle of the other triangle, then those two triangles are congruent to each other according to side angle side rule. Okay, those two triangles congruent to each other according to side angle side rule. Therefore, EB equals to ED according to the rule that corresponding sides in congruent triangles are equal to each other, and also those two angles are equal to each other, or angle CEB equals to angle CED. Those two angles are equal to each other, and we define those angles as x. Okay, so the sum of those two angles is x plus x. So actually BD is a straight line, and the sum of those two angles, that is actually the size of angle DEB, is 2x. So the size, we know that DB is a straight line, and we know that the size of angle DEB equals to 2x from one side, but angle DEB also equals to 180 degrees from the other side, because of the fact that on one side of a straight line the sum of the angles are equal to 180 degrees, and this is DB is a straight line. So if you look from the one side of this straight line, the sum of the angles on one side of the straight line is equal to 180 degrees. Therefore, angle DEB equals to 180 degrees from the other side. Okay, so from this equality we deduce that 180 degrees equals to 2x. Here we can divide this equality by 2 and we will get that x equals to 90 degrees. Angle x, so angle DEC that equals to x is 90 degrees, so this is a right angle, and angle CED that is also equals to x is a right angle, it equals to 90 degrees. Okay, so we have those two angles that are right angles, and then we know that OC is the radius of the semicircle. Therefore, OC is also a straight line. OC, that is the radius of the semicircle, is a straight line. Therefore, angle CEB that equals to 90 degrees plus angle BEO will be equal to 180 degrees, because we know that along a straight line, if we look only on one side of the straight line, the sum of its angles is equal to 180 degrees. So the sum of the angles for one side of this straight line OC is equal to 180 degrees. That is to say, the angle CEB is equal to 90 degrees plus the size of this angle, that is angle BEO. Okay, so angle CEB equals to 90 degrees plus angle BEO, and in total the sum of the angles in one side of a straight line, that is to say on one side of OC that is a straight line, the sum of the angles on one side of OC is equal to 180 degrees. So this angle that is 90 degrees plus this angle that is angle OEB must be equal to 180 degrees. So angle CEB that equals to 180 degrees, it actually equals to this angle that is 90 degrees plus angle BED, and in total the sum of those two angles must be equal to 180 degrees. So here we can subtract 90 degrees from this equality, and we will get that the size of angle BEO equals to 90 degrees. So this angle BEO equals to 90 degrees. Okay, so we actually have three right angles around point E. This is a right angle, this is a right angle, and this is also a right angle. So we have three right angles that the sum of them is 270 degrees, and we know that the total sum around any point equals to 360 degrees. So 360 degrees minus the sum of those three right angles, that equals to 270 degrees. So 360 degrees minus 270 degrees must be equal to this missing angle, because the sum of the angles around a point is equal to 360 degrees. So we have three angles that equals to 90 degrees plus so the total sum of them is 270 degrees, plus this angle must be equal to 360 degrees, because the sum of the angles around a certain point is equals to 360 degrees. So 270 degrees plus this angle must be equals to 360 degrees, and 270 degrees plus this angle equals to 360 degrees. So we can subtract 270 degrees from 360 degrees, and we will get that this angle equals to 90 degrees. Okay, again, 360 degrees minus the sum of the three right angles must be equal to the missing angle. This is actually angle OED. So we got that angle OED equals also to 90 degrees. So all the four angles around point E are right angles. Okay, then we focused on two triangles, on triangle ADB, the big triangle, and on triangle EOB. In those two triangles, we have those two angles that are right angles, therefore they are equal to each other. We have common angle that belongs to both triangles, and then those two angles must also equal to each other according to the third angle theorem. The third angle theorem states that if two angles of one triangle are equal to two angles of another triangle, or if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are also congruent, or the third pair of angles are also equal to each other. Okay, so if you have two triangles that have two equal angles, then the third pair of angles must also equal to each other. Therefore, we actually proved that three angles of the big triangle, triangle ADB, are equal to three angles of triangle OEB. Therefore, we also actually proved that those two triangles are similar triangles, because they have three angles that are equal to each other. According to angle, those two triangles are similar to each other. Triangle ADB is similar to triangle OEB. Okay? So from this similarity between the two triangles, we can derive the following relationship between the sides of those two similar triangles. According to the similarity that exists between two similar triangles, OB over AB must be equal to OE over AD. Again, OB over AB must be equal to OE over AD. Okay? OB over AB equals to OE over AD. But what is the value of OB? OB is the radius of the circle. So OB is R. But what is the value of AB? AB is the diameter of the circle, so it equals to 2R. AB equals to 2R. OE is OE, and AD equals to 7 units. AD equals to 7 units. So we got this equality, and from this equality we got that OE equals to 7 over 2 units. OE, this line segment, OE, this line segment equals to 7 over 2 units, and EC equals to OC minus OE. Okay, EC equals to OC minus OE, and OC is the radius of the circle, and OE equals to 7 over 2. Okay, so OC is the radius and OE equals to 7 over 2. So in total we got that EC equals to R minus 7 over 2. EC equals to R minus 7 over 2. So then we focused on the two right triangles. Triangle ECB is a right triangle because angle CEB is a right angle, and triangle EOB is also a right angle because angle OEB is also a right angle. So on those two right triangles we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and then we have the equality that states DE square equals to DE square. We should remember that side DE is a common side. It belongs to the right triangle CEB, and it also belongs to the right triangle OEB. Okay, so DE square is, if we relate to this triangle, if we relate to this triangle, DE square equals to CD square minus CE square. Okay, and what is the value of CD? CD equals to 15 units, and EC equals to R minus 7 over 2 units. EC equals to R minus over 2 units. So it is actually DC square minus EC square is DC is 15, so DC square is 225, and EC equals to R minus 7 over 2, so EC square is R minus 7 over 2 units. So, and also DE square equals to R square minus OE square. Okay, DE square equals to R square minus OE square. Okay, and OE equals to 7 over 2. Again, OE equals to 7 over 2, so OE square is 7 over 2 square. And actually I related when I related to DE, and I said that it belongs to, it is a common side of two triangles. Actually DE belongs to triangle DCE, to this right triangle, and it also belongs to this triangle, to this right triangle that is OED. Okay, so we solved this equality, and we found out that we have a quadratic equation that states that 2r squared minus 7r minus 225 equals to 0, and the coefficients of this quadratic equation is a equals to 2, B equals to minus 7, and C equals to minus 225. And then we have the formula for solving the quadratic equation that states that x, when the quadratic equation is ax squared plus bx plus c and x is the variable, then the value of the variable will be equal to minus b plus minus root of b squared minus 4 times a times c over 2a, when a, b, and c are the coefficients of the quadratic equation. In our specific quadratic equation, we know that a equals to 2, b equals to minus 7, and c equals to minus 225. And the variable of our quadratic equation x is equal to r. Okay, so we put all the coefficients and we substitute x by r. Okay, and we solve this quadratic equation by using this formula for solving the quadratic equation, and we found out that the radius of the semicircle equals to 12.5 units. But we have another solution to the quadratic equation. R equals also to minus 9, but because of the fact that the radius of a circle is a positive number, this possibility is cancelled because it is a negative number. So we left only with the possibility that the radius of the semicircle equals to 12.5 units, and the diameter of any circle equals to 2 times the radius of the circle. So the diameter of the circle is 2 times the radius, that equals to 12.5 units. So 2 times 12.5 units equals to 25 units. So the diameter of the semicircle equals to 25 units. Again, A, B, that is the diameter of this semicircle, that equals to 2 times the radius of the semicircle, equals to 25 units. Okay? Thank you very much.